One of the sucky things about encryption, rant continued, is that it's all bespoke. So there's don't roll your own crypto. And what that refers to is the algorithms. What they're saying is don't write new crypto algorithms, which is what the blockchain space is best known for. All of their weird non-standard crypto algorithms. They just throw that advice out the window and say, oh, is there some obscure crypto algorithm that people aren't using that isn't well tested, and that's the daggone repository, the only one repository in the entire earth that has this algorithm codified in code, says in big letters on the front, do not use, insecure, beta, alpha, not tested. But even if you pick a good standard cryptographic algorithm, such as AES-CBC, so that's what we're talking about right here. So there's AES-CBC 256, and you don't need 256, 128 is sufficient. Using 256 is overkill. It's like the difference between shooting someone 1,000,000 times in the head versus shooting them a quadrillion times in the head. 50 shots will do it. 1,000,000's already overkill. Going to shooting them once for every star in the sky, and keeping in mind that when you see a star, what you're actually most likely seeing is an entire galaxy, but you only perceive it as a star. That galaxy has millions of stars in it. Point being, AES-CBC is a standard algorithm, but how you pack it is bespoke. So you can think of it like this. You can get AAC audio in many different formats. You can get it in M4A as an unencrypted audio file with the Apple M4A container. You can get it as an M4V or MP4. Both of those, I think, are the same. They might actually be different. You can get it in a MKV. I mean, for heaven's sakes, you could argue that .zip is a container. I mean, it is a container, but it's another layer of container. So anyway, something like AAC, a standard audio stream, you can get it in about 15 different ways. And I think 15 is not an exaggeration. I think that might be underplaying it, or maybe it is, but it's in the realm of a dozen or so, right? You can get an AAC in a lot of different ways. An MP3 you can still get in a fair number of ways, but it's not as widely implemented, I think, as AAC is. Oh, ACX, the Audible format. M4B, the iTunes book format. There's a lot of different containers for AAC. And likewise, if you have AES, there's a lot of different ways to do a container. You can have this thing that's called the initialization vector. You can have it at the beginning of the data. You can put it at the end of the data. It's basically a random salt. I won't go into that for the purposes here. You can look up some other videos on that perhaps if you're interested. But essentially there's some bytes that you can either put at the beginning of the file or the end of the file. And it doesn't really matter where you put it. You could put it both at the beginning and the end of the file if you want to protect it against corruption, because it is critically important. It's basically a second password. So there's the passphrase that you give, and then there's that whole bit. You could take your passphrase straight, but you're probably going to SHA-SUM it. You might be doing what's known as a key expansion algorithm on it. You do a certain number of rounds, say 1,000 rounds. Basically, you do a checksum on it 1,000 times. So you checksum it, and then checksum the checksum, and then checksum the checksum, so on and so forth. Do that 1,000 times. That's basically what PBKDF2 is, which I don't even know what that stands for anymore, but I can say it fast. When you encrypt something, basically every program that encrypts something encrypts it in its own bespoke way that has one of a dozen different varieties of permutations. So you probably could create a program. No, you really couldn't. You really couldn't, because there's so many things that are just dependent that unless you know about the file, you just can't decrypt it. So for example, how many rounds? I guess if you knew for sure what the password was, if you 100% knew the password and you just didn't know how to decrypt the file, you probably could write an algorithm that would try initialization vector at the front, initialization vector at the end, initialization vector at the front and the end, with the number of rounds in each popular key algorithm. I don't know. It would be less expensive than trying to crack the algorithm itself, which would never happen, at least not on any known way in the known universe. There are so many different variations. If you use standard algorithms, it's a matter of which standard algorithms. So you could use AES and PBKDF2, and just if you knew that those were the two algorithms implemented, there'd still be so many different ways that you could use the different parameters for those two things that it might not be possible to decrypt a file if you knew the password and you knew the algorithms because of all the other parameters.